Hello and welcome to the Beat Cancer Answer, brought to you by BeatCancer.Org, the Center for Advancement in Cancer Education. We believe that 90% of all cancers could be eliminated through environmental and lifestyle choices alone, and science agrees. Unfortunately, most people don't know it, so we provide the education that can help you prevent, cope with, and beat cancer through diet, lifestyle, and other immune-boosting approaches. On every podcast, we will feature an expert who can teach us how to become part of that 90% who could prevent getting diagnosed with cancer. If you already have cancer, we have empowering information for you too. Over the past 35 years, we have helped thousands of cancer patients get back into the driver's seat when it comes to their personal journey of healing cancer and preventing future reoccurrence. Listen now as BeatCancer.Org founder Dr. Susan Silberstein interviews world-renowned biochemist Dr. T Colin Campbell on his research of using nutrition to sustain long-term health.
It is a true pleasure and honor for me to speak with Dr. T. Colin Campbell today, a world-renowned biochemist who specializes in the effect of nutrition on long-term health. Dr. Campbell is an expert on the scientific evidence that a low-fat, whole-food, plant-based diet can prevent and even reverse killer diseases like cancer, heart disease, and diabetes. He's the author of over 300 research papers on the subject and several books, including The China Study, one of America's best-selling books about nutrition, Whole, Rethinking the Science of Nutrition, and The Low-Carb Fraud. He was featured in the 2011 American documentary Forks Over Knives and is featured in another film, Plant-Based Nation, about to be released. Many of you know that Dr. Campbell was one of the lead scientists of the China-Oxford-Cornell study on diet and disease, which was set up by Cornell University, the University of Oxford, and the Chinese Academy of Preventive Medicine to explore the relationship between nutrition and disease. Dr. Campbell is also the Jacob Gould Sherman Professor Emeritus of Nutritional Biochemistry at Cornell University. Prior to joining Cornell Nutritional Science Division, Dr. Campbell was a research associate at MIT and worked in the Virginia Tech Department of Biochemistry and Nutrition. He is a senior science advisor to the American Institute for Cancer Research and sits on the advisory board of the Physicians Committee for Responsible Medicine. Dr. Campbell, thank you so much for taking the time from your incredible schedule for today's interview, and welcome.
Well, thank you so much, Susan. Pleasure.
It is a real honor. So explain a little bit, when did you first get interested in doing research on cancer, and especially the relationship of diet and cancer?
Well, I think if I can go back that far, I had a little background somehow since the time I was about 4 or 5 years old when my aunt had passed away from cancer, and her husband, my uncle, took my brother and I down to see her almost every day, and I was very young, and I said, when I get big, I'm going to work on cancer, kind of thing.
Oh, wow.
So, I mean, that's sort of, you know, how those things go. We all say these things when we're young, but somehow it kind of stuck with me, I think. And then when I was at MIT, I was involved in, very little actually, on the role that a mold toxin, aflatoxin, causes liver cancer. And I wasn't so much involved in that as I was sort of associated with a group who was doing that. But in any case, I left MIT, came to Virginia Tech, and then I took up the aflatoxin story pretty actively. And that led me then to the Philippines, where in 1965 I got involved in helping to coordinate a nationwide program of feeding malnourished children in the Philippines, and we wanted to make sure they got enough protein, you know, like everybody thought. And but one of the sources of protein we thought made sense was peanuts.
No.
But unfortunately, peanuts was contaminated with this compound called aflatoxin.
Right.
So one thing, I mean, I was wearing two hats in a sense. So on the one hand, coordinating that nationwide program of feeding malnourished children, you know, paying attention to the protein question, and on the other hand, being concerned about the aflatoxin causing liver cancer thing, and we couldn't really adopt peanuts as a source of protein that well, you know, knowing full well that it could be contaminated. So then I got involved in seeing a linkage, I thought, between the amount of protein consumed and the amount of liver cancer formed presumably coming from aflatoxin.
Wow.
So that was between the years of 65 and 68, and that the rest of it is my story. I got a grant from NIH, and the major grant I got lasted for 27 years. Actually.
Oh my goodness!
It kept getting renewed all the time, and we had a chance to really work with the relationship between protein and liver cancer, and that all started out as a bit of a surprise because what I was seeing and thought I was seeing first in the children and secondly in the laboratory, that higher protein intake basically increased the probability of cancer. I thought, wow, that's kind of crazy because we were going there to make sure everybody got enough protein, but in reality it was this, this odd observation that higher protein might mean more cancer.
Wow. So
that was it, pretty much.
So, what was so unique about your research in China? We're all fascinated by the China study.
Well, the China study, that word applies first to the title of the book, of course, and the book has done very well. The China study itself, I call it the China Project, that was conducted in the early 1980s and was conducted throughout the 80s on into the 90s. Cornell was the lead. I was the director of the project, but we had partnerships or collegial, partnerships with my friends at the University of Oxford and also in China. And actually, that was a human study, as I'm sure most people know. We were interested in seeing why it is that cancer was so common in some counties in China and not in others. And I thought it was a good opportunity to go there and just survey a bunch of these villages, that were quite different one from another. And we took blood samples and urine samples and food samples and all that sort of thing, and measured just a huge number of things because I was getting interested at that time in doing, I suppose, two things. One was I was becoming aware that it was hard to describe a cause of cancer as, by one thing, one nutrient or one this or one that or something else. And because I was becoming quite aware that in nutrition things work together, if you will. And so that was one purpose, to sort of look at cancer in a comprehensive sense with respect to nutrition. But on the other hand, I was particularly interested in this question concerning protein. Mm-hmm. All the work we had done in the laboratory at the time. And we determined, I was really interested in developing principles in that research in the laboratory. Principles that might apply, of course, across species and apply to different nutrients and maybe different cancers and so forth and so on. So the China study was actually an opportunity to take a look and see if in a human population the results that I thought we were getting in the laboratory, to see if they might be the same or maybe different. And so the China study became sort of an affirmation, essentially, from a very broad perspective on the relationship between nutrition and cancer. Mm-hmm. And other diseases, I should say, as well, especially the ones like heart disease and so forth. So, so the China study, the China project and the results from that project, I must say, and this too many people sort of maybe take it too far, that the results of that study did affirm, as I say, the laboratory work on the one hand, but on the other hand, the results of the China study were not sufficiently analytical and determinative, standing alone. I mean, we looked at all these correlations and associations and things like that, and I found some interesting ways to look at patterns of correlations and in order to get some really good information. But that kind of study doesn't lend itself to, making firm conclusions, to be honest about it. But when it's added to the other kind of study that information we did have, and the information others had, then it became quite powerful.
And the main conclusion was that a Western diet heavy in animal protein and animal fat is contributing to chronic degenerative diseases. Did you conclude that from that study? Those studies?
Yes, definitely. I mean, as I said, I was looking for patterns of food consumption in a sense. And so it turned out that diets rich in animal-based protein and sort of deficient, if you will, too, in the proper amount of plant consumption. That kind of diet is what really seems to have been. It was basically increasing the risk of Western kind of diseases, as you just said, the cancer, the heart disease, and diabetes, and so forth.
So the plant-based proteins, with the notable exception of the peanut legume, they are generally a much safer form of protein.
Yeah, actually, the plant protein in peanuts itself, that's very good protein. The reason that the peanuts were associated with higher liver cancer, essentially in laboratory studies, the reason for that was not because of the protein, it was because of
the aflatoxin.
Yeah, the aflatoxin, right.
Right, but since is it very hard to get peanuts that are aflatoxin-free?
No, actually, in those early days, there was a lot of concern about that, and we got into the media, and it made quite a lot of news in the early 60s when that was first being discovered, before I got involved. And then there was a great deal of interest on the part of the FDA to see how much aflatoxin was really in peanuts, especially here in the United States. And between 1965 and 68, I actually had a contract with the government at that time to survey the aflatoxin content of peanuts and corn and soybeans, actually, the three crops. And so I got quite involved with the FDA in that. Mm-hmm. And I became convinced, to be honest about it. I mean, I tend to be quite critical at times of some of the government activities, as you probably know. But in this case, the FDA did a pretty good job of working out ways to keep that under control. And they did it because when aflatoxin is produced by the mold that's in the peanuts, that gives off a sort of a blue fluorescent color. And so you can sort of take what we call a black light and just sort of hold it over some peanuts and see if there's any hot spots, if you will. And so the FDA had done a pretty good job of figuring out how to screen peanuts. In fact, I say a pretty good job. I think they did an excellent job, actually, because they got to a point where they were able to survey large batches of peanuts, if you will, and to see if there was any aflatoxin contamination. And I was satisfied. They really did do a good job, and I don't think we need to worry about that at all.
So you're saying that peanuts are safe today?
Yes, definitely.
They are aflatoxin, very low in aflatoxin at this point.
Right. They're below, technically speaking, they're below 4 parts per billion, which is an extremely small amount. And that's really, really low because the amount that might cause cancer in humans would be, let's say, 1,000 times or 10,000 times higher. So it's so low it's really meaningless. But the other side of that story, by the way, or additional part of the story, we did some work on this, actually working with human liver and things, is that the human, surprisingly, is not very susceptible to that compound in the first place.
Interesting.
The experimental rat is, the experimental mouse is not, and the human is sort of like the mouse. We don't seem to respond to that. So I'm perfectly and totally confident that the only thing I would say, and this is kind of interesting, is that when a large lot of peanuts, or if they become contaminated, it's usually because only about 1 out of every 1,000 peanuts or 10,000 peanuts is pretty moldy. Mm-hmm. And so it's a spotty thing. And if we're eating them peanuts in our ham, for example, which a lot of people do, you shell peanuts. If anyone comes across a peanut that is darkly colored or looking a little bit moldy, get rid of it.
Right. Right.
That's really what the story is. And so I think the aflatoxin story, which I became really deeply involved in for about 10 years, both on the regulatory side as well as the research side, I think we're in good shape.
Well, that's good to know. Is there a certain percentage of animal protein in the diet that you would consider reasonably safe in terms of cancer?
Zero. And the reason I say it, but let's stick with me just for a second here to try to explain this. It turns out if we determine how much protein we need, let's say total protein we need in our diet in order to create good health, and protein is obviously a very important nutrient. It turns out the amount of protein we need is around 8 to 10% of total calories, as you may know, and that's near what the RDA is. That's the amount of protein that we all do well to stay near that. And we can get that level of protein from plants only.
Mm-hmm.
So
yes,
plants have all the protein we need, but we don't do that. You know, the vast number of us in our country, we start adding in animal protein, whether it's in meat, milk, or eggs, or whatever it is. We start adding those kinds of foods to our diet. And so as a result, the average American diet has about 70% of the total protein we consume is actually from animals.
Yes.
That's not a good deal. And so the total protein is getting up around 17-18% of total calories. You know, as I say, about 70 to 75% of that is animal-based. And so we have to think about that, obviously.
So we should aim for close to 0% coming from animal protein.
Yeah, I just say 0%. That's why it was one of the major reasons I say whole food plant-based diet. But the protein, in fact, I want to point this out, it's really important, and that is that the protein has its direct effects, and there's much evidence and all kinds of mechanisms by which the animal protein can do its damage, including increasing cancer and blood pressure that cause heart disease. But it also, by consuming that kind of food, we actually end up displacing the foods that really count. The good foods. We tend to displace the whole plant-based foods.
Yes.
So it's a sort of a double whammy. On the one hand, getting the direct effects of the animal protein, losing the good effects, the plant foods that we otherwise would be consuming.
Right. And I'm sure that your findings differ from what is generally believed by cancer researchers and oncologists.
Definitely. I became immersed over the last 4 or 5 decades almost, in the whole sort of the larger question of cancer in humans. What do we do and how do we try to resolve that problem? And just by all means, I'm saying something very different than what oncologists generally are taught.
Yes, and what they generally recommend, which is a high-fat, high-protein, high-calorie diet. We've been talking about animal foods. Let's talk a little bit about cow milk. And I believe that you stated that casein, is that how you pronounce it? Casein?
Yeah, casein.
Casein, which is a protein in animal milk, and is the most significant carcinogen we consume. I'd like you to elaborate on that.
Mm-hmm. Okay, well, we tend to believe, and this is a very fundamental assumption that almost everybody believes it consciously as well as unconsciously, we tend to believe that cancer that is caused by food is attributed to the environmental chemicals that's present in the food. We call them carcinogens, of course. And so that's been a widespread belief for a long time. And sure enough, we've got some chemicals in food, foreign compounds, if you will, environmental chemicals and odd things like that, that theoretically, when they're tested in the laboratory, can be shown to have some properties that could lead to cancer. That's been sort of the bedrock belief and assumption for a long time. And there's a particular program that the FDA and the NIH has administered for more than 50 years, sort of routinely testing for these chemicals that we have in the environment that get into the food and water. They've been testing these various assembly chemicals, of which are said to be about 80,000. I don't know what the number is, but a large number of possible chemicals. And they've been testing these, and each test costs a lot of money just to do a test. It usually involves a couple of species being tested, at 3 or 4 different dosages, for a couple of years. And in any case, and then they finally determine whether such and such a chemical can or cannot cause cancer in experimental animals is what they do. And they have very strict rules and protocols for doing that. And it's done by, as I say, the FDA and NIH, and a big laboratory program. We call it the Biochemical Carcinogen Bioassay Program. And in any case, using those rules to determine what is carcinogenic and what's not, we usually ending up with a chemical we might discover in laboratory animals that does cause cancer, if you will, but the level that's actually used in those studies is, it's usually 3, 4, 5 orders of magnitude higher than anything that humans might expect. So it raises the question about how significant they are. And in human studies, we go and then start looking at human studies to see if whatever chemical is we're talking about, whether or not we're really getting exposure to that or not, and whether that exposure is related to increased incidence of human cancer. That kind of information is surprisingly lacking. And so, much of our research actually was focused on just that question. How much effect does, let's say, aflatoxin, which is a very potent carcinogen, at least in the experimental animal setting, how much does that matter compared to, let's say, the ability of nutrition to control that effect? And that was, I think, the major strength of our research over the years, looking at that in many ways. It turns out it's the nutrition, imbalanced nutrition, that actually sort of controls the activity of these chemicals that otherwise might be carcinogenic. Now, the chemicals that are carcinogenic are usually mutagens. They cause a mutation, and the level of protein actually controls the rate at which those mutations are caused, when it feeds those chemicals. Now, having said all that, it really suggests that, in our case, for example, in the studies that we did to considerable depth, those mutations involve genes. You get a new gene in the cell, theoretically it can cause some cancer. But actually, the protein causes and other nutrients too. They control the expression of those genes. Mm-hmm. And so the major effector of cancer is nutritional in origin. What I find really exciting about that is that there are a number of nutrients that can do this, working together, almost in infinitely complex ways, and they can cause cancer. But here's the part of that that's really the essential part of it is the fact that what we learned in our research is that we could reverse cancer by simply removing the nutrient in question. And, of course, you asked a question about casein, and that's what we've mostly worked with. And it turns out that the level of casein, usually the levels that other animal proteins will show this more or less the same thing, the level of casein that actually causes the increase in cancer is well within the range of our everyday consumption.
Wow.
And so that makes it just an entirely different world from the chemical carcinogens. In the experimental animal studies, for example, we can take aflatoxin, which is the most potent carcinogen ever discovered, at least for that animal, and they could be exposed to the highest possible dose, but they would not get cancer if they had low-protein diets. Uh-huh. If we then added casein and started elevating the level of casein in the diet within very reasonable, normal limits, we could just turn the cancer on. If we removed it or replaced it with plant proteins, we could turn it off.
Wow.
So we could turn it on and turn it off. And so this is a phenomenon that got me very excited because, for one thing, it shows the power of nutrition to control cancer formation.
And does it take a long time? Excuse me for interrupting. Does it, when you say we can turn it on and turn it off, is that a process that happens pretty quickly?
No, well, yes, it does. It actually, in our hands, in our research, you can see this kind of thing begin to occur easily within 3 or 4 weeks. It's quite remarkable. In fact, the biochemical mechanisms that lead to that actually can occur within hours.
Wow.
So, in any case, so the protein thing in our hands was able to turn on and turn cancer off. That led, and I really became acutely aware of this as years passed, this leads to the very basic idea that the progression of cancer from this initial genetic mutation, the progression of cancer, we tend to assume in cancer research, and most people assume this, that cancer is a progressive disease that is essentially irreversible once it starts going down that road, to the formation of cancer, and evolves over, some, perhaps, certainly months, maybe years. The cancer starts growing. And what we're now discovering, what our research shows very clearly, we could stop that, turn it backwards.
Can you clarify the various stages in the cancer process for us?
Yeah, the model that we tended to use in experimental work was that we tend to assume that cancer occurs in 3 stages. This is kind of arbitrary, but it was a convenient way to describe it and do the research. But the first stage is initiation. That's a stage during which the chemical causing the cancer, the initial stage of the cancer, that's the time during which that chemical is ingested, metabolized, and causes a mutation change or genetic change. That's the first stage. Converts a normal cell to a cancer cell. That can happen within minutes, or certainly within hours, as long as at the time we get, consuming that carcinogen, if you will. But the next stage, promotion, is a stage that can gradually occur over a period of weeks, months, years even. And that occurs, as we get exposed to the offending agent. In this particular case, if we were to consume higher animal protein, for example, on a regular basis over a period of time, it just gradually keeps on promoting the development of cancer. It's a slow process sometimes, but it'll keep on piling it up. Mm-hmm. And that may require some time. The third stage is what we call progression. That's when, in theory, let's say cancer is diagnosable, and it's in a fairly late stage. It may at that point in time be such that it begins to metastasize and cause other kinds of problems. This, in the case of humans, it's a later stage, obviously.
But even at that stage, it's reversible.
Well, the second stage, actually, the first stage is reversible. No, I'm sorry, it's reversible at the time it's forming. But once, I've got to spend a little time here. When we get exposed to these chemical carcinogens and they start causing our mutations, there's an intrinsic capability of the body to actually repair all that damage. And so we have what we call DNA repair mechanisms. Mm-hmm. That's just an intrinsic part of biology. And so our body does a great job of repairing any of that DNA damage or mutations. It has a great job of reversing that fairly quickly. And most of that kind of damage will occur. Maybe 99% plus of the damage occurs is repaired. But unfortunately, there is a cell here and there who, that in theory, once the damage occurs, at that point, let's say it's dividing. It's forming some new cells, new generation of cells. If that damage occurs at the time the cell is dividing, then that new mutation in those cells will be retained by the so-called daughter cells. And so there you have it, and that's not reversible. That's basically not reversible. Once we plant the seeds, as I say, the genetic seeds, most of them are all repaired very quickly, but there's a little bit of that, they may escape the process. And so we end up with some cancer seeds or genetic seeds that can cause cancer going forward. But and that's going on all the time, and we all have in our tissues, I'm sure, some of these kind of little mutated cells that can give rise to cancer. That's not necessarily, even then, it's not going to be of much concern if we eat the right diet, do the right nutrition.
Right.
We just keep it under control.
And we talk at BeatCancer.Org, we always talk about changing our biological terrain and trying to establish an internal environment that's unfriendly to cancer. So even if there are malignant changes taking place, we can keep them from progressing.
You're so right. You said that well. You really said that well.
Thank you.
That's exactly right. We have lots of things going on in our body that, fortunately, that's who we are, and that's how biology evolved. That the immune system, the hormonal system, enzyme systems, and so forth and so on. If we're in all those systems are working together to create an environment, the tissues, to keep things under control.
That's
and
wonderful.
It operates throughout the whole cancer process.
Let's speak very quickly about your book, Whole, and some of the topics it covers.
Well, when I wrote the China study with my son, who incidentally is a physician now himself, but in any case, the China study was my attempt to basically see if I could tell a story that made sense based on all the research we had done. it was almost as much writing for myself as was anyone else, to see if, when you think about it in the world of context. So that told the story. Here's what we could do. But it didn't deal too much with why we haven't heard this before. And I thought about that, but I decided to sit down and write a book whole to try to delve into that question. Is there something about the science that we don't understand and that we've been promoting that maybe is not right? And so it came up to this idea. It's actually an old idea, I have to say, to some extent, but it's the idea that biology is extraordinarily complex, as we all know, which means a whole lot of possible causes are involved in causing various and sundry diseases, operating through a whole bunch of different mechanisms, infinite, countless mechanisms, so to speak, biochemical mechanisms, to cause a whole variety of outcomes, be they cancer or heart disease or diabetes or whatever. And so it's a very dynamic process. Biology is very dynamic, infinitely complex. We'll never, ever know all the details of it. It's impossible.
But the good news is we may not need to.
We don't need to, exactly. We don't need to. You're so right. We don't need to do that because we ought to have some faith in our bodies to do the right thing. And all we need to do is provide our bodies the right food.
Wonderful.
And it just works out. I mean, we in our whole business in science, I think, in the last decades and century, whatever it is, we tend to ignore what nature can do.
Yes.
And we always want to make things so mechanical, and we want to develop now these days targeted drug therapy, to sort of hit this, that, or something else we don't particularly like, which is really kind of ridiculous, because that's the whole nature, the basis for the whole pharmaceutical industry, incidentally.
Well, yes. And that's why I always feel that this elusive search for the cure, we're kind of fooling ourselves. We have the cure. The body is the cure.
Yes, absolutely. We just got to stand, get our heads out of it and let our body go to work and do what it wants to do. We just have to provide the right resources.
Well, thank you for all the groundwork you have done for so many decades. Tell us now, Dr. Campbell, how are you spreading the message on your findings beyond the books that you've written and the research that you've done?
Well, we're doing a number of things, and I say we, in this case, I'm talking about my family, my children who are very much involved in this too. For one thing, we've had the books, as you just mentioned. Now there's additional books, too, by your son, daughter-in-law, and so forth. But the second thing is that we'd like to focus on is education. So in that case, we have a nonprofit organization that I developed a decade ago or so. And we're offering an online course in plant-based nutrition to try to elaborate some of these points for the public. Because this is not the kind of thing you want to get in nutrition textbooks, I can tell you. Mm-hmm. I taught it that way for many years. And so we're offering a different approach to understanding the role of nutrition and disease formation. And we have this online course. Our partner in that is the online course program of Cornell University. So we're partnering with Cornell in this, and we have that course, and we offer 30 continuing medical education credits for physicians and appropriate other, professional credits, and that's done really well. Cornell offers something like 200 some courses online now, various topics, and ours is number one of all those courses. So that's something that we've been doing. My son, who co-authored the book with me, Tom, he was in theater, then he went back to medical school. He's a physician now. He's on the faculty at the University of Rochester Medical Center, and he's just been named the director of a new nutrition and medicine program.
You must be very proud.
He's going to be carrying that forward. He lectures with me some, and he's written a book called The Campbell Plan that just came out just recently. Mm-hmm. Some may think I'm biased, but I think it's a pretty good book. It's written primarily with a great deal of professionalism. It's good for doctors and others.
Well, I think that's very important because until the doctors start delivering these messages to patients, they're going to be going down the wrong paths. Absolutely.
That's exactly what we're going to be doing. So we got education in 2 or 3 different ways. We also have been doing the films, too, and the first film, Forks Over Knives, was not my doing. It was developed by a group out in some experienced people out in Hollywood, but it was founded on the China study in large measure.
Right.
They came to us one of my lectures. So Forks Over Knives have done fabulously well.
But you have a new documentary film now.
Yeah, that's a documentary film out right now. And it's supposed to be, according to some rankings, close to being the number one documentary film of all documentary films during the last 4 years, actually.
Now, is that Plant-Based Nation?
No, that's Forks Over Knives.
Oh,
so
Forks
then,
Over Knives,
that,
yes.
Like the China said, that's sort of basically, Dr. Esselton, my really good friend and colleague on heart disease, featured our work, his work, my work, and that's sort of, again, just sort of telling the story to the public to say, hey, look here, look what we can do, kind of thing. And that was sort of the message of that film. And it was a surprise to a lot of people. But we didn't, again, in that film necessarily go into the reason why we hadn't heard it before. So the new film, which is directed by my oldest son, Nelson.
And that is Plant-Based Nation.
That's Plant-Based Nutrition, PlantPure Nation. We're very excited about that. We just finished up 18 cities on a tour screening that film. It's going to do some more on the West Coast, but it's coming out in theaters on July 4th.
Wonderful. Well, maybe
so that's so film is it? Books number one, education number two, film number three, and then our daughter, who is a doctor of education, has gotten very interested in this. She went to Peace Corps in the Dominican Republic, and so now she's starting to join and put on conferences of her own, especially bringing more women into the discussion. There hasn't been enough women. I mean, women are their chief caretakers. We all know, we do know that, and they're responsible for buying food and stuff like that. And so she's been arguing, rightfully so. More women need to be informed of this in the proper way and participate. They need to be participants in this. So she put on a conference, and she's putting on one down in the Dominican Republic this October. She did it before with a cardiologist from Canada. That's all very exciting. So conferences, online stuff, education, books, films.
Wonderful. This is wonderful. We cannot get enough education. That's, of course, the focus of BeatCancer.Org, which is unique in that most cancer organizations are raising money for research. We know the research is out there. We need to teach people how to apply that in their daily lives. So I'm just thrilled to have this opportunity to have a small collaboration. We did get some pretty good responses for your pre-release of PlantPure Nation, but I'm excited about the July 4th release, and we hope that the whole country gets to see that film and learn from it.
Yeah, I would like to actually put on a plug for your program. I know you've been at this for a long time, longer than almost anyone, and the public. And I just know it's a fabulous website. It's really, really well. And
thank you.
I just want to congratulate you on what you've been doing. I've been sort of following over the years, off and on. But gosh, you're doing a great job.
Well, thank you. That is a great compliment from someone of your stature, and we're quite honored to have this opportunity to talk with you. Is there any one message that you would like to leave with our listeners today?
Yes. I spent about 20 years in national policy development, on expert panels and giving testimonies and stuff like that. And that was an experience that really educated me about the question concerning why we haven't heard this before. I feel really badly about the way that the public is not being told this. And I really hold accountable, my own academic community, the scientific community, for this, as well as other sectors of our society. And so I can't say it strongly enough that the public is not being told the information they need to know. Wow. And it's really they're not being told. In fact, it's not only is just an absence of information and an absence of that kind of research. Unfortunately, it's too much. Some certain sectors of our society are actually being proactive in actually trying to refute this information.
Mm-hmm. So
and I just find that really annoying and really pretty disgusting. So I think the public, I've worked out now some arguments, I think. I've found that they really resonate with those not in science as well as those in science. And that is, I've got 5 so-called industries in my mind that are founded on fundamentally flawed scientific basis.
Wow.
One of them being the cancer industry.
Yes.
The whole idea that somehow we're not even actually examining what the causes are properly, and we're certainly not determining what is the best way to treat people, once it occurs. So the cancer industry is one that we need to change that around and get this fundamental science explained in a way in which everyone can understand, why it fundamentally is flawed.
Do you want to go into the other 4?
Well, the other 4, one of them is the pharmaceutical industry, where we take foreign compounds and we single out a single chemical here and there to develop it into something that's quite toxic, and we try to attack our illnesses through single chemical approaches. Or even if we had a few different chemicals in the same pill, it doesn't make a difference. We're basically using a very reductionist approach to treating disease and creating health, and that is bound to fail. That's not working. Mm-hmm. It might, in the short run, we might see some evidence from time to time that it looks good, but that's not the way to. All we're doing is treating symptoms.
Right.
We're not getting at the reversal of the whole thing. So the pharmaceutical industry is the second one. The third is the nutrient supplement industry. I know there's a lot of fans out there, and they spend over $30 billion a year buying nutrient supplements, but we now are finding that in a lot of studies that are put into meta-analysis kind of things are showing they don't work. And
well, they're very fractionated, and we need the whole food phytonutrient
That's right.
complex.
Yes, that's exactly right. We take out one thing out of the food, and we say we're going to do one of those things with it when in fact it's the whole food that matters, not that. And so this nutrient supplement industry is the second one. The third is the food industry itself. We know there are problems there, big problems. As just illustrated by the recent U.S. Dietary Guidelines Committee report. The whole kind of message that's being told to the public of what's good food and what's not, and the way we actually study it, the question itself, is really seriously flawed. And so the food industry needs a redoing. Mm-hmm. The pharmaceutical industry, the cancer industry, the nutrient supplement industry. And the fifth one is, I would call it the medical practice community. And the medical practice community, a lot of wonderful people practice medicine. I admire them. And they need to be the leaders going into the future. But, they're not taught nutrition in medical schools.
No, I know.
So they're operating on a very reductionist sort of model of caretaking, and that doesn't work the way it should.
Not only that, but especially in the cancer field, we're only concerned about the anatomy. We get rid of the lump or the bump and the symptom, then we think we have a cancer cure, when in fact we have to focus on the body's physiology.
Yes,
where the breakdown
absolutely.
in the body chemistry is. So, yes, those are 5 flaws. Well, I hope God blesses you with enough longevity to change the flawed foundations for all 5 of these fields. But if not, then your children and those who follow them will take up the battle cry, and I'll keep at it as long as God keeps me vertical.
That's great. That's great. It's challenging. We all know that. It's very challenging.
Yes.
But I would suggest that one of the reasons it's challenging is because we haven't articulated the really fundamental information well enough so the public can understand. And it's the kind of information that those 5 institutions don't want to be told. This is really what it is.
Well, you made a big contribution to the articulation today, and I'm so grateful for your time, Dr. Campbell.
Well, it's a real honor for me to speak with you and to sort of have another look at your program. It's been great. I just sort of want to congratulate you for what you've been doing. There's one, just might make one comment here. I was looking at just getting up to date on some of your material. There's a blog post on there by Samantha O'Toole.
Yes.
Okay. I really like that.
I did too. A registered dietitian who's looking at holistic healing.
And she tells the story how she, with her own creative thinking and her own experience getting into the nutrition field, or part of the problem is this, is seeing that it wasn't exactly for her liking, and then doing the training, going out, and then trying to do things right. The way she explains it is really good.
Well, I was thrilled to invite her to do a blog post when I learned how she thinks and about her experience, and I'm glad you noticed that.
Yes, it's good. Well, thank you so much.
Thank you, and I look forward to seeing the new film.
We'll be talking again. Thank you.
Bye-bye.
Thank you so much for joining us on the Beat Cancer Answer. If you learned just one thing today about how to prevent, cope with, or beat cancer, then we have succeeded in our mission. For more information or assistance, visit our website at BeatCancer.Org. Remember to sign up for our educational email series and get your free gift. Join in the conversation on Facebook, Twitter, or Google+, where you can meet others who think just like you. We appreciate all of your feedback and love your suggestions. Please also remember to rate us on iTunes. Your positive ratings help us to get discovered so we can save more lives. Thank you again for listening, and best wishes for good health from all of us at BeatCancer.Org.